so let's work through an example where we are applying the central limit theorem. According to data from the National Health and Nutrition Exam Survey, the mean weight of 10-year-old boys is 88.3 pounds with a standard deviation of 2.06 pounds. Assume the distribution of weights is normal. Suppose we take a random sample of 30 boys from this population. Can we find the probability that the average weight of the sample will be above 89 pounds? If so, find it. If not, explain. So the last part of the question, the if so, find it, if not, explain, that just means that we're going to be checking our conditions of our central limit theorem. Right, so we're going to start like we have in previous problems over the last couple of chapters with a list of things that we know. So our population is all 10-year-old boys. Our sample size is 30 that were sampled. Our mu is our population mean. Right, so our population mean is 88.3 pounds with a standard deviation of 2.06 pounds. That's going to be our sigma. So 88.3 pounds. Sigma is 2.06 pounds. Right, and what we want to know is the probability that the average weight of our sample will be above 89 pounds. So going back to notation that we used in previous problems in Chapter 7 when we were talking about our central limit theorem. We started with a capital P outside for probability. And then we were using p-hats because we were talking about proportions. Well, we're not talking about proportions anymore. We're talking about means. But we're thinking about our sample mean. So our sample mean is represented by x bar. Okay? And that's going to be greater than or equal to 89. So this is what we are looking for. What is the probability that the average weight of the sample will be above 89 pounds? So x bar is greater than or equal to 89. Our sample is random and independent. Again, we're going to assume that that is true unless we are told otherwise. Do we have a large enough sample? So one thing we want to go back and we want to look at our problem. We want to look at the information about the distribution. Our distribution is normal. So in this case, we technically, our sample size doesn't matter. Is it large enough? Yes. But since our distribution of our weights is actually normal itself, our sample size isn't going to make a difference. So for this, I'm going to say the probability distribution is normal. So sample size does not matter. Right, do we have a large enough population? Is our population, right, all 10-year-old boys greater than or equal to 10 times 30, which is 300? Yes, that is a pretty safe assumption. All right, so step 2, we're going to find our normal distribution. So in order to do that, we need to find our standard error. So our standard error is sigma divided by the square root of n. So our sigma was 2.06 divided by the square root of 30. If we divide this out using our calculator, we get 0.376. Right, so our normal distribution that we get has a mean of 88.3 because that was our original mu. And then our standard error that we just found, this 0.376, is what we're going to use to do our problem. All right, then to finish this off, we are going to go to StatCrunch. We're going to go back and we're going to use our normal calculator as we did in Chapter 6 and as we did in Section 7.3 when we were doing our other central limit theorem problems. Right, so we're going to find our probability using StatCrunch. First we're going to draw a sketch and then we're going to finish this by writing our answer in a sentence. So the sketch I'm not necessarily going to get super fancy with. I am going to mark my mean. My mean is 88.3. We could go through and mark our standard deviations going to the left and the right, but I'm not necessarily going to bother. 89, based on our small standard deviation, we're going to guess it's somewhere right around here. And we're thinking our probability that we are larger than that, so we're going to shade in this little tail over here on the right side. All right, so in StatCrunch, again, we're going to do stat. We're going to go to calculators and then normal. Right, and then the information that we're going to enter. We're going to enter our mean, which was that 88.3. Right? Then we're going to enter our standard deviation. Now this is generally the place where I see mistakes as we're going through these problems. We don't want to use our original standard deviation. We want to use this standard error. That was the whole point of finding that value. So when you're plugging stuff into StatCrunch, absolutely make sure that we use this number when we plug that in. So our standard deviation is going to be 0.376, right? And then what we are testing for our mean to be greater than or equal to 89. Right? And then when we're in StatCrunch, after we have all of this information in there, we're going to select compute, and it's going to give us 0.031 if we round it off to 3 decimal values. So the probability that the mean of the sample is greater than 89 pounds is about 3.1%. So in our sentence interpretation, we want to make sure we include what we are looking at. So we're looking for the probability that the mean of our sample is greater than 89 pounds. And then we're going to take that, and in this case I wrote it as a nice percent. The 0.031 I wrote as 3.1%.